Hello everyone, and welcome back to Net Mastery Zone and to another video from CCNA series. In this video we are going to speak about the LLDP link layer discovery protocol. As you see, this is a link layer, and it's a layer 2 protocol, and it's used to send and receive the information about the neighbor, and this information is sent through the directly connected peers or neighbors. It means that if you have a switch in the middle, that you will not receive the information from that switch from another switch, because it's working with directly connected actually ports. And you know that the LLDP it's open standard, and it works with different network products. As you know, there is many vendor that producing the network devices like Cisco and like Foundry, and I can say the Nortel and so on, and all of them actually have a protocol for this to send this information. And if we have a homogeneous network, then we don't have any problem because we are using the same vendor devices, and then this protocol will work very well. But if we have a multi-vendor and we use heterogeneous environment, if we be in heterogeneous environment, as this is I can say the most networks in the world is actually it's heterogeneous. It's not easy to use the same product for all departments, for all parts of the network, and because of that it's very important to make sure that this heterogeneous devices can send and receive the neighbor information to each other, and for that we can use this LLDP, link layer discovery protocol. What actually LLDP do? The LLDP send the information about the chassis number, about the port ID, description, host name, and other information like you can see the IP address, the MAC address, and so on to its neighbor. And this information in the neighbor side will store in the local management information database that called MIB, and it's I can say a temporary database that save the information in that, and this information then can be used by network monitoring softwares like SolarWinds or Manage Engine or something like that to actually draw the network diagram automatically, and also monitor the network devices that this port is up or down and so on. And of course this information will send using SNMP, the simple network management protocol, and it's another protocol inside this devices, and this protocol actually is used to send this information to the other monitoring softwares. Actually, how the LLDP used, as I said, you can see that the network monitoring software, it's I have a link here, and you can check that what network monitoring is. And this network monitoring using the SNMP to query this information from the MIB and get this information, and according that information it just draw the network diagram, and also shows the information of the up, down, or any other maybe error messages, or for example in duplex messages and so on. This information will be show up on the monitoring software. And of course here we are going to speak about the Cisco LLDP, that's called CDP, Cisco Discovery Protocol, and it's not much different from LLDP, and just different protocol, and working with different way. It's the same actually CDP is same like LLDP, but has two different versions, the CDP version 1 and version 2. Of course, the version 2 the new is the new version, and also it's actually sending extra information like VLAN IDs, and also if there is any problem with the mismatch, as you see in the previous videos, when we add two ports in different VLANs in two sites, then we will receive a message that there is a mismatch in the native VLAN, and also it will show the mismatch of the duplex state of between the connection. And what is duplex? Duplex, actually we have a half duplex and full duplex, and the half duplex sending and receiving will happen separately. For example, a router send the information and it doesn't receive the information at the same time, then it just wait, stop sending and just waiting to receiving the information. But in the full duplex, sending and receiving the information will happen in the same time. And how CDP works? Actually, CDP is working by sending the packets in the you can see that the default time interval value is 60 seconds, and in every second that it's sending this information, and also the packet actually use the TTL, time to leave, and the value is in the seconds, and the default value is 180. And if after 180 seconds it just receive information from the other side, then it's okay. But if it doesn't receive that, then this device will assume that the other side is down. And also the CDP sending this value, sending the value like when for example we just shut down a port, and when we shut down a port, before it shut it down, it just send the value, send the packet with the TTL of 0, and then the other side will instantly know that the other side is down. And also we can say that this CDP packet process, it's like when information received in a switch, you just save that in the MIB, and when the new information comes, actually the old information will remove and the new information will take the place. And in this case, if even the TTL is still time to leave is still not 0, again it doesn't matter, it just remove that information and update the MIB with the new information. And one thing more, that when the CDP packets actually received in a switch, then the switch never forward that packets to any other switch or devices. It just store them in the MIB. And if any monitoring software wants to use that, you should be connected using the SNMP to this switch, and then read this information from the MIB table. And also we have some information about the CDP that I believe I speak about that in the previous slides, but still there is some new information. And as I said, the CDP already only works on the directly connected link, and you can see that it's generated every 60 seconds, and the old timer is 180 seconds, and then it sends the information in the multicast address of this. You know about this multicast address when we actually configure the port channel. You saw that there is a multicast MAC address also in that one to send the information to, and also and also when the device receive information, just store them in a MIB table, and actually with this show CDP neighbors, we can see this information inside the MIB table. And also the CDP table information, as I said, is refreshed and each time, and when the new information received, that information will overwrite with the old information. And all time the old time, specify the lifetime of any entry in the table. If no announcement received during this whole time, actually that device is assumed as a dead device, I can say. And we can actually run the CDP on all supported sub-network access protocol, SNAP, and that is include of course the LAN, frame relay, ATM, and so on. And also CDP, as I said, it's only run on the layer 2 protocol, and even this because it's a layer 2, even if it is the IP address is blocked in the other devices, this information will be sent. And as I said, we have two versions. The version 2 also send the information about the VLAN mismatch, and also about the mismatch of the duplex ports, of duplex and full duplex. Also, we can enable the CDP on the GRE tunnels. You will learn about this GRE. I believe it's more belong to the security. It's a tunnel that we can create between two devices and encrypt the information inside that. And also the DNVPN, and DNVPN also, it's another I can say protocol that we can connect to our network from remote site using the internet or using the MPLS and so on. And actually the CDP is working on this too also. And also I can say that the CDP is used to negotiate to the power in the PoE ports. You know about the PoE, power on Ethernet, and when we connect a device, all devices actually doesn't use the same voltage, for example, as power. Then this CDP will use to actually to send the information about the voltage that this device needs to use. Then when this information received, they are negotiated, and they will select required voltage for that device. Okay, our presentation is done here. You can download this presentation from the comment, but now let's go to the our network and actually run some command here. As you see, I just created this network. It's an example in the EVNG. And again, you can find a video about the configuration and installation of this EVNG. It's more realistic than packet tracer, because the packet tracer is just a simulator, is simulating everything. Before I just tried to make this in the packet tracer, but it doesn't have the behavior that I was expected from that. But here in the EVNG, it's not a simulator, it's an emulator actually, and it's using the Cisco iOS. Not Cisco iOS, is Linux, but it's designed for this, and you can use this for see the more realistic value about the CDP and also other protocols. Okay, let's first go to the switch and check the CDP neighbor actually here. Let's first speak about the CDP, then we can actually configure also the LLDP here in the Cisco switch. The command is show CDP neighbor, and in the CDP neighbor you can see the all neighbor that is connected to switch 1. That is switch 2 in the port 0x1. You can see this is the local port 0x0, and this is the remote port actually. The port ID is 0x0 again. And for the other device, you can see for R2, router 2 here, and the local port is 0x2. And the other side port, the remote port, is port 0x0 that you can see here. And also we can see some detail about this. This is the show CDP neighbor details, and this will show all information about the details of these devices. For example, first one is switch 1, and here you can see that the interface Ethernet 0x0, and the outgoing interface is 0x0. The outgoing, it means this one, because it's all information about the switch 2. And also you can see about the version, the vendor, and okay, also you can see the advertisement version, that is CDP version 2. As I said, it's showing the duplex information also. And also you can see that it's a VTP, VLAN trunking protocol, the management domain of that, and because there is no VTPs configured here, actually it's just showing the management domain as a none. And also native VNAS is 1. And if we go to the other devices, you can see that this is router 2 here. And also because this is a router and it has an IP address, it's also show the IP address of the other side, and some other information about the version, and also again about the you can see about the duplex here, the full duplex or half duplex, and also the IP address here. Actually this protocol can be very handy because if you go to a server room and connect to a switch and try to find that this switch is connected to which neighbors, then you need to actually trace ports one by one and find the other side and see it's connected to which devices and to which port. But here with the CDP neighbor, show CDP neighbor, actually you can easily find that this port 0 by 0 is connected to the other side, and that is a switch 2, and it's connected to 0 by 0 in the other side. And also for the router, you can see this detail actually exactly for one port. For example, show CDP neighbor E0 by 1. And here you can see I only see the information about router 1, and if I give the detail here, you can see the detail also. And for example, if you need to SSH to this device and you don't know what is the IP address of that, then you can actually with the CDP neighbor find the IP address of the other side of router 1 and then SSH to that or ping that or anything else. By default, as I said, the CDP is run on all devices, and we can turn it off by command no CDP run. And now the CDP is turned off. Do show CDP neighbor, and you can see that the CDP is not enabled in this switch, then it doesn't have any information. But to turn it on, just CDP run, and now the CDP is turned on, and now we should see the information. Show CDP neighbor, and now we didn't receive the information. As I said, this information will send every 60 seconds, and if this after 60 seconds this information will come to this switch. And now you can see the switch 2 and switch and R1 is send the information, but for R2 is still waiting to send the information after 60 seconds. You can see that the whole time for them is okay, this whole time it's actually is decrementing, and after this all time is expired, if the other information comes is okay, it will stay in this table, and if the information not come from the other side, then this device will be removed from the table, and it's assumed as a dead device. And one thing else that I speak about that it was about the duplex actually. Let's actually change the duplex of this devices, and this one of this port, and we'll see the information that will come up when we change the duplex here. Let me enable this and see when I change the duplex what will happen. In R2, I'm not going to configure this in R2, I'm going to configure that in switch 1. And which port is connected to R2? The Ethernet 0 by 2 is connected to this port. Let's go to Internet 0 by 2. Internet is 0 by 2, and let's configure the duplex to full. And now I don't know the other side is full duplex or half duplex. We have to check that actually. Do show CDP neighbor, and interface is 0 by 2. Is 0 by 2, and detail. In the detail you can see that the other side duplex should be half duplex, because I just received a message about that. Yes, the duplex is half duplex, and when I configure this as a full duplex, then it just give me the message in the router 2, and you can see that this is not a full duplex. With the switch 1 is full duplex. Then we have to change this side or this side to remove this message. Let's go to interface 0x2 and change the duplex to half duplex. Now both sides as the same duplex, then this information will not appear anywhere in this two devices. And one thing more I can say about this, and actually to how to configure the LLDP. The LLDP is same as like the CDP, just the command LLDP run, and now the LLDP actually is enabled here, and now we can check the information about the LLDP here also. Okay, now if I run the command show LLDP neighbor, you can see that I have information about the LLDP in switch 2, because it may be enabled in the other side. Let's check that. Let's go to switch 2 and see. Show LLDP neighbor. Yes, you can see that it's also has the information about the switch 1. It means that the LLDP is enabled here. But if I go to R2 and run the command show LLDP neighbor, here you can see that the LLDP is not enabled here, and it doesn't have any information. To turn it on, let's go to that and just command LLDP run, and now the LLDP is also enabled in the R2. Show LLDP neighbor, and now you can see that this it should receive the information. It's not received yet because it's connected to switch 1, and switch 1 is as a LLDP. Let me see here. It also doesn't receive any information about that. It may take some time. And also actually let's go to the configuration of LLDP. You can see that we can configure the hold time for that. We can configure the timer, and also the delay for that, and we can configure this for LLDP. Let's see if the information come here. Show LLDP neighbor, and now you can see that the switch 1 is appear here in the table, and now it just receiving this information. And also it's like CDP neighbor. We can run the command details, and in the detail you can see it has some different information. Of course the port and other information is here, the name, the port that is connected, the MAC address, and also some vendor information. And here you can see the timers, and also system capability says here, and what actually this B and R means. It should has a guide here. You can see that the B means is bridge, and R it's a router. This is the capability of this, and capability is enabled, the router is enabled, and so some other information here. Okay, one thing more that I'm going to show you here. For example, let's go switch 2 and let's run the command show LLDP, and here you can see the information about the LLDP and also the CDP, that you can see this information about the timers and also the status of the LLDP protocol here. But in the CDP it doesn't show anything about the status, but when it shows the information that this information available here, it means that this protocol is activated in this switch. Okay, I believe we have to finish our video here, and we speak about the LLDP and also CDP, and we said that the CDP is a Cisco protocol. It's only working in the Cisco devices, but you have a heterogeneous network and many different vendor network devices. Then you need to enable the LLDP, and it's not much different between LLDP and CDP in the command, and you can see the information from other side and from heterogeneous of course network devices. Okay, let's finish our video here, and thank you for your watching. Please subscribe us, and also please leave me a comment if you need to learn about some specific technology, and I will try to create video about that also. Thank you for watching, and see you.